Hello again from Minnesota. My name is Joey Morisette. I'm also on the Anaplan team, our internal center of excellence. And what I'm going to be talking about today is how we are structuring our models internally to conform to our best practices and to optimize them in such a way that we enable our businesses and enable each user and end user to successfully build and maintain and use the models that we have internally. So a little bit of background I wanted to go over. This presentation is structured around model design. However, that doesn't mean that if you're not a model builder, that it's not relevant to you or that you shouldn't care. These principles help the model builders and the end users create sustainable, scalable, and models that make sense. And so there's a few key benefits I wanted to highlight in terms of how does this impact me, and then what does this mean for the business? So a few of the issues we are addressing in the solutioning of our models is business continuity, transparency, and confidence in the data the models are producing, the model performance, and sustainable and scalable models. And so a little bit more detail on business continuity. A few of the problem areas that we were finding is that someone would leave, a model builder would leave, we'd lose that knowledge, we'd have overly complex models that didn't make sense to anybody else except for the person who built it. And also, when we were onboarding new people, we were realizing that the models that we had were increasing in complexity and were hard to get someone up to speed in terms of the logic and what exactly was even going on in that model. The second set of issues we were trying to address is the transparency and confidence the end user has in the data. So this one really pertains to both the model builders and the end users that are using the model but not actually building it. And what we found was this allows for the people that are not building the models to really have a full understanding of exactly what the models are doing, have a very transparent and easy to follow chain of logic for each of the calculations, and understand the data sources and where they're coming from, and if they have questions about a specific set of data or where the model's sourcing something from, that they can quickly go and identify the team that's responsible for that data and talk to them about it. And the second thing we found was that as a byproduct of what I just talked about, there's increased confidence and due to the validity in the reporting the model's producing. So with the transparency comes the ability to be confident in what you're looking at is correct and to know that there's no errors or logic missteps in the model. And what really allows for that confidence and transparency is the model performance. So the model performance, really this is what the entire model architecture best practices I'll be talking about is structured around, but not only just in the way it's structured, but also in how the model behaves. So what we found is by optimizing the models in such a way that we're taking full advantage of Anaplan's amazing calculation engine, that we are able to increase the amount of concurrent users the model can handle. So if we have a widespread model, say a sales planning model where you have a ton of sales reps going in constantly, that we can allow for more of them to be in the model at the same time without seeing a decrease in performance. A few of the other byproducts that you'll see as part of rolling out these best practices is that the models take less time to load because there's less redundant calculations going on. They're optimized to only need to do the things that the model needs to do to load and get you to where you need to be. And then the last thing is decreasing the calculation times, and this is especially important for the end users of the model when you're inputting data into the model or you're trying to scenario plan or run multiple calculations as part of your user experience. We found that the calculation times significantly decrease and allow for a much smoother end user experience. And the last, and perhaps in my view, one of the most important concepts that optimizing your models solves for is sustainability and scalability. As your business grows, your models will inevitably grow with the business. Data sets get more increased in size. The calculations keep increasing in the model. You're doing more things, more use cases. And it never gets smaller. Your models will almost always get bigger. And so as we allow the model to grow with your business, by utilizing these model architecture best practices, You reduce the need for periodically having to rebuild your models, having to re-optimize them in a way to where they can handle the increased calculations and data loads that you're inserting into the model. And then it allows for a completely continuous and seamless transition into your growth phases. And so with all of these benefits that we've realized, let's go ahead and get started in talking about what exactly is the best practices for model architecture. You may have heard this term. We have it out on Community. There's several articles that we can provide the links to. The concept is DISCO, and you may hear it as discoing your models or applying the DISCO methodology to your model architecture. So what exactly does that mean? DISCO is an overarching concept in terms of how the modules within each model interact with each other. And so by defining a set of functional areas for each type of main purpose each module is responsible for, it allows us to streamline and have a much clearer and organized system within the model to produce the user experience and calculations that the model is supposed to. So the individual letters in DISCO are fairly easy to remember. There's five letters. There's data, input, system, calculation, and output. And each of these have a very defined set of responsibilities within the model and for the desired functionality that they're supposed to perform. Data is very straightforward. What this is your transactional data. This is your data coming in from other sources, whether it's your CRM or another model within your business. It can really come from anywhere, and any external source, this is where we want the data to land. This is only a staging area for data that is not coming from the model itself. The second letter in DISCO is I, and this stands for input. Input is also very straightforward. This is where any module that contains data as an input target by an end user. So if you have your end users going into the model and updating ramping profiles for sales reps or changing allocation percentages, things like that, where the end users are entering this in on a dashboard, this is where we want the data to flow. The third is system, and this is one of my favorite ones. This is where we're storing all of our static calculations, or to think of it another way, these are the things that don't change as you're modeling. So a good example, and I'll show you this, I plan to walk through a example model with you, but a good example is time management module. And so you can think about this as if you're doing a previous calculation, or if you want to bring in the month before whatever month period you're in. So say you want to say April comes into May. You don't need to perform that calculation multiple times within the model, because the logic and the desired result of that formula will never change regardless of where you are in the model. So rather than have that calculation exist multiple times, just store it once in a time management system module, and then reference it as many times as you need in the other modules. And this is also where we want to store the mappings and the hierarchies and all of the technical data that you're using to drive your calculations of the model. Again, those are not changing or changing very infrequently and will be made by the workspace administrators of the model and are not changing often by the end user input. The fourth letter is calculation. So this is the heart of your model. This is the calculation engine where all of the magic happens. So what these are modules optimized for performance. These are not output modules. We have a separate letter for output. These are where the meat of the calculations and logic reside in the model, and these are not to be seen by the end users. These are internal to the model, and where we're staging all of our data and performing all of the complex calculations that you need to drive the O in DISCO, which is output. And output is the reporting modules. These are the modules that you're actually seeing on your dashboards. These are the ones that you're creating charts off of and presenting to the end users of the model. And also, as part of the connected planning vision, when you're having multiple models talking to each other, you need to very clearly define which sets of data other models have the ability to reference, so that you're not pointing another model owned by someone else in your company at the wrong set of data. So output is not only intra-model reporting on dashboards, but also where you should stage all of your information and outputs that you want to send externally to other models within the business or to other systems as well, not just Anaplan models. And the key thing for output is this is only incoming data. We should never be sending output data back to a calculation module or having outputs feed systems or input modules. And as we'll see on the next slide, there's a very clear diagram of how we optimize the data flow within the model to take advantage of Anaplan's hyperblock technology and the calculation speed and ability that it has. So those are the 5 letters of Disco. These are how we were thinking about organizing our modules. And the key takeaway here is that we're taking advantage of Anaplan's capabilities by organizing in such a way that Anaplan understands and thrives in for calculating and handling data. And then this is all of a guideline. So this isn't just an organizational practice where we're organizing our modules by all of data or input or systems. This is more of a conceptual, this is how we want you to think about organizing your models. This is how you should think about organizing the model when you're solutioning it out. So not even before building, what we found internally on the Anaplan team is even before we touch Anaplan, as part of the solutioning of the problem or request that we have, when we're building a new model, we will diagram all of this out, say what are our main data input, system, calculation, and output modules, and we'll have a clear schema of how we plan to handle the data flow to and from the model before we even start building an Anaplan. As I mentioned, I wanted to show a quick slide on what this looks like in practice. So as you can see, there are multiple dependencies on each module for the other types of Disco modules we have. But the key concepts to take away from here is you can see output only has incoming data streams. Data is only outgoing, so we don't want to be sending anything back to data. System also is only outgoing. System should be static calculations. And then, as you can see, the heart of the model is the calculation type modules. And so this is where all of the data is aggregated. This is where everything is coming together and then sending the results of the calculations to the output modules. So why do we do this? We've talked about addressing the business needs, but let's get a little bit more technical into how we're addressing those business needs and how Disco helps us achieve that. There's another concept we're championing, and it's called plans. And so this is performance, logical, auditable, necessary, and sustainable. And so what plans is this is how you should be thinking about building your models. This is, how do I optimize the model for performance? How do I make it logical? How do I make it auditable? Is what I'm doing in the model necessary, or do I even need it in the model? And then how do I make the model sustainable for the long term? And so this is the behind the scenes look into how we're addressing the business problems I previously talked about. And so by using Disco, we're increasing the model performance by eliminating redundant calculations, eliminating unnecessary recalculations, reducing the model size. So by doing those things, we're already realizing performance gains within the model itself. From a logical perspective, the architecture is intuitive, it makes sense. We don't have a bunch of circular references going between 5 different modules and you're never able to actually find the source or the genesis of the calculation. Building becomes much easier. It's much quicker to go in and implement a new change into the model. And you also have improved model navigation since you're able to follow calculations much quicker. And then by tagging the modules, whether you're renaming them to show the Disco methodology, which you'll see in a second when I go into the model, the example model is how we're doing it. And then another aspect we've realized is that the collaboration aspect is much improved, because rather than having to spend 5 minutes on the phone trying to describe to another model builder where something is within the model, it's much more concise and clear, saying you want to go to this data module, or you want to go to this systems module is where that calculation is housed. And so you'll see how it's much easier to navigate the models as a side effect, if you will, of discoing your models. Again, auditability and sustainability, these are really to increase business confidence and to remove the need to constantly rebuild and re-architect your models. So with auditability comes increased confidence in the data, quicker ability to build within the model, and then it's easy to trace the dependencies and understand the logic in a much easier way. And then necessary is a little bit of a subcomponent of performance, where if we're doing things 5 times within the model, if we're doing the same thing 5 times within the model, why are we doing that? Why don't we just do that once, and then we'll have increased model performance? Everything will make much more sense because we know if we're doing that calculation, we only need to go to one spot. And then, again, sustainable, we're thinking about the long term. Your business is going to grow. You need your Anaplan models to grow with it. So rather than having to constantly readdress growth issues or re-architect your models, rebuild the models because you don't understand them anymore, you have a very seamless transition between where the model is today and where it will be in the future as your data and calculation needs grow. And so what I'll showcase in a minute is a demo model, and I've taken 2 screenshots from the demo model that I wanted to talk about really quickly here and see how this looks in practice. So you'll see these are screenshots directly out of the demo model. And so what you can see here is we have the exact same chart I just showed on the right-hand side, and then detailed-wise, you can see when I enhance the precision of the model map, you can see, okay, these are all of the modules within the model and how they're talking to each other. And what I wanted to highlight here, and as part of the auditable and sustainable and increasing business confidence aspects of discoing, is what you can see is there's a very logical progression of data flow on the left-hand side model map on my screen. And you can see your data in blue and your systems modules in green are on the left-hand side, which makes sense because those have no dependencies on other modules in the model. Those are either static calculations that you're housing in your systems modules or incoming data feeds from other models. And then as that data flows from left to right, you can see it's then staged in the yellow calculation modules and then ultimately feeds into the output modules that we have for the end users and also for exporting to other Anaplan models. And so with setting the stage for that, I wanted to go ahead and jump into the Anaplan model itself that I've mocked up to show the DISCO methodology and walk you through a few things that we've found to be best practices here. So again, I'll jump into this model map that we just talked about. So this is the same model I just showed. And if we break it down a little bit further by precision, you can see left to right, same thing. And so what we found to be a best practice internally, and we've enjoyed organizing our models in this way, is naming the modules within the model with the DISCO area that it falls into. And so you can see here we have our data, input system, calculation, and output modules. Now, while we're doing this internally, this is certainly not a way that you have to conform to with your models. Understandably, there's business needs and there's logical ways to organize your modules that you don't necessarily need to organize them according to the DISCO methodology. You may have, for example, in a planning, budgeting, and forecasting model, you may have revenue calculation functional areas, you may have operational expenditure areas, things of that nature. So build to the use case that you're doing and build to what makes sense to you in terms of organizing the model. But we do recommend either naming the modules according to DISCO, naming the functional areas according to DISCO, or you can also take advantage of our data tags or the notes section within the model itself. And so what you can see here is we've chosen to name all of the modules according to DISCO. And like I was saying before, one of the benefits of doing this that we found is that when we're building concurrently with other model builders, we have a very clear way to talk about the model. So rather than saying, oh, well, you need to go, for example, to that module that calculates wins. I'll set the stage a little bit. I'm a big Formula One fan, so I've done this around the Formula One universe here. So for example, if you're talking to another model builder and you're saying, oh yeah, go to that module that's doing the win analysis. Well, okay, that could be 5 different modules. Explain to me in detail how I get there. What we found is, well, now we can just say, okay, go to your calculation 2 module. Boom, you're there. There's no confusion, there's no ambiguity. You're speaking the exact same language, which is great. And so what we found is a few of the example systems modules that we have in almost all of our internal models across what we call the Anaplan on Anaplan ecosystem of models is there's a system time management module which I wanted to showcase. And so this is what I was talking about with the systems modules. As you can see here, month start date, start. If you're referencing the month start date in a calculation in 3 different calculation modules, you don't need to recalculate that start date every single time in every single module. It's not going to change based on the dimensionality of the modules or the logic you have in those modules. The month start date is the month start date. So why make Anaplan recalculate that 5 times every time you refresh a calculation? Let's store it in one spot in a systems module where we can go out and then reference this line item here as many times as we need. Because when we reference it, it's only having to recalculate once. It's not having to recalculate it in 5 different modules. So this is a great example of a systems module. A few other ones, you can see here, we're storing like our country hierarchies. We're doing custom mappings where I'm combining 2 different data sets of country data where I'm mapping nationalities to countries. So things like this that are static, are fixed, will rarely change, are perfect examples of things to store in your systems modules. With data, what we found is that these are the modules that are great at being the target areas for incoming data feeds. So your raw data, your transactional data from your source systems, great example is maybe you're just only bringing in codes and then redimensionalizing it out by your list in the model itself. As you recall, these modules do not have any incoming feeds. These are simply target modules for external data feeds coming into the model. And then similarly, what we have here is an input module where where I'm assigning talent levels to the Formula One drivers in my model. And so this would be something that maybe an end user comes in and says, okay, I want to do an analysis to see how my talent levels are spread out across teams. Let me make some adjustments on a dashboard, entering them into the input module, and then that will feed the calculation models and ultimately the output modules that I see on the dashboards. And then similarly, we have the calculation modules where we only have incoming data streams and we're performing calculations in an optimized way. And a few things to note here is that these are not intended to be presented anywhere on a dashboard externally. These are simply driving the output modules that we'll see in a second. And so knowing that, there's a few things that we can take advantage of. One, optimizing them in such a way that the model performance is optimized. So a good example of that is summaries on the calculation modules, unless they're being referenced in a calculation module or output, should always be turned off. And that way you avoid the need for Anaplan to recalculate those summaries. And then lastly, we have the output modules. And so what you can see here is these are your custom reporting fields where you're doing, you're consolidating the data from your calculation systems, input modules, and data modules into one single spot, and then you're doing whatever logic you need to be able to present that data to the end user. And so these, like I said in the model map, these should only be the output modules should only be the target and have incoming data streams from your other modules. And so you can see here, all we're doing is bringing data in from either our data, our calculation modules are a few examples, and then this is what will be presented on the dashboards of the model or be made available for other models within your Anaplan ecosystem to reference and import actions into their models. And so by doing that, you have a very clear and defined staging area for that information, and you avoid confusion and people pulling the wrong data out of your models by having a single spot and a single source of truth for what they have the ability to export. And so with that, that will conclude the presentation on our DISCO methodology. I hope you found this useful. We've realized so many benefits from this methodology between the end users having more confidence in the data, the model builders being able to build quicker and more efficiently, and then ultimately we're optimizing Anaplan's performance, and that's what's driving all of these benefits that we're realizing, is that we're taking full advantage of Anaplan's amazing calculation engine and amazing platform. So I hope that was helpful, and I hope you learned something today. Thank you very much.